Hello, everyone, and welcome back to the Collaborative Science for Estuaries webinar series. This is Nick Sobral with the Science Collaborative, joined remotely by Megan Brass. Thank you for joining us for this month's webinar, and today's topic is stormwater. So before we get too much further into the presentation, I'll just give a bit of background on the reserve system, the Science Collaborative, and the webinar series. The National Estuarine Research Reserve System, or NERRS, is a national network of unique research reserves as shown on this map. This is a NOAA program that works in collaboration with a local place-based partner, either a state agency, university, or nonprofit. Each reserve site includes programs focused on land stewardship, research and scientific monitoring, training programs for the public and local officials, and education. The Science Collaborative supports science for estuarine and coastal decision makers by coordinating regular funding opportunities and supporting user-driven collaborative research, assessment, and transfer activities that address critical coastal management needs identified by the reserves. The webinar series features project teams supported by the Science Collaborative, program staff, and partners. Speakers share their unique approaches to addressing current coastal and estuarine management issues. If that sounds interesting to you, join us for future webinars to learn more about new methods to integrate technical experts and users of project outputs into the research process and how their research results and products might inform your work. So some brief housekeeping notes. All attendees are muted upon entry. We'll be handling questions via the question and answer feature on the GoToWebinar console. You can enter questions for the presenters as they occur to you throughout the webinar using the Q&A feature, and we'll discuss as many as we can during the final portion of today's webinar. The chat is visible to organizers only, and you can use it to alert us to any technical issues you might experience during the webinar. And with that, I am glad to welcome two members of the project team to present today. Dr. Rachel Noble is a Marion Watts Hill Jr. Distinguished Professor of Marine Science at UNC Chapel Hill. She is a land-water interface scientist who works with diverse stakeholder groups, including municipalities, counties, and state, regional, and federal government to understand the interplay between contamination and remediation strategies. She has also devoted extensive attention to understanding flooding and resilience of coastal communities in the context of extreme events. Whitney Jenkins has been the coordinator of the North Carolina Coastal Training Program since 2002. The goal of the program is to promote informed coastal decisions through science-based training for professionals. Whitney is also responsible for developing and facilitating collaborative learning processes for groups such as the North Carolina Sentinel Site Cooperative. And with that, I will pass it to Whitney.
Thank you so much, Nick. It's a pleasure to be here today. Again, I'm Whitney Jenkins. I'm the training coordinator for the North Carolina Coastal Reserve and National Estuarine Research Reserve. Before we get into the meat of the project, I just wanted to give a little bit of context because, as Nick mentioned, the National Estuarine Research Reserve is a network of sites across the country. We all have the same federal partner, which is the National Oceanic Atmospheric Administration. And here in North Carolina, we partner with the Division of Coastal Management. When our sites were established back in the 1980s, the state decided they wanted to add more sites onto our program to increase the reach and protect more coastal and estuarine habitats. So that's how the North Carolina Coastal Reserve interacts with the National Estuarine Research Reserve. And you can see that really on our map here. So the sites in blue are federally designated sites. So starting in the south, you have Zeke's Island and Masonboro Island near Wilmington, the Rachel Carson Reserve, which I can almost see out my window, Currituck Banks, which is almost at the Virginia border. And then we have these 6 additional sites that are in green that are state sites. And in total, we protect over 44,000 acres of coastal and estuarine habitats. So our mission is to practice and promote stewardship of coasts and estuaries through innovative research, education, and training using place-based system of protected areas. And we accomplish this through 3 major program areas, which is research, education and training, and stewardship. And we allow compatible traditional use on our sites, fun things like hiking, kayaking, and beachcombing. And then this project that we partnered with Dr. Rachel Noble on is focused on stormwater impacts. So I just wanted to give a little bit of context on what stormwater and water quality means to the North Carolina Reserve. Let's see. So research, we've been conducting water quality monitoring through our system-wide monitoring program since the 1990s. Our education and training programs focus on water quality for teacher and students, and also stormwater management for decision makers. And then, of course, water quality impacts our sites as well as our visitor experience. So stormwater is an issue that we are very interested in. And for this project in particular, we are focusing on the Rachel Carson Reserve, which is adjacent to the town of Beaufort, North Carolina. And I just wanted to show this aerial image to give a little context of the importance of the Rachel Carson Reserve to the town of Beaufort. It's a major storm barrier. It's also a part of our tourism economy here. People come to the reserve to, be out in nature and visit the site. And the reserve is separated from the town of Beaufort by Taylor's Creek. And then you can also see to the south, we're near Cape Lookout National Seashore. So with that, I'm going to turn it over to Rachel.
Great, thank you very much, Whitney. We began working as a collaborative team on this project in 2016. And I'd like to tell you kind of one snippet today of the many facets of research that we worked on. But before I do that, I wanted to recognize up front the town of Beaufort, the Coastal Reserve Office, which you just heard a little bit about, and also the Duke University Marine Laboratory Community Science Initiative, because those entities together, along with multiple additional entities that participated in the project, like the North Carolina Coastal Federation, made it truly collaborative. Nick, do you want to take over? My computer doesn't seem to want to advance the slides.
Happy to. If you try human real quick, just click on the screen on the slides and see if it lets you advance. No? Okay, I'll advance for you.
Great. So quick outline of the talk is that the collaborative approach will be brought up and defended from the very start of the project. We're going to talk a little bit today about stormwater and wastewater research outcomes from the project. I'll spend a very brief moment talking about some innovation that we worked on in collaboration with the Duke University Marine Laboratory on using an autonomous boating system to track water quality. We're going to also talk today a bit about community learning, collaboration, and providing some final thoughts on the project. Next slide, please. So for the collaborative approach, I would make the argument that for stormwater, and now with wastewater as a main concern in regards to infrastructure across the nation, but also most needed in attention in the southeast and along the mid-Atlantic seaboard, are that municipalities in North Carolina and along the seaboard are faced with multiple stressors. Coastal reserves themselves, as you just saw from Whitney's presentation, are themselves intertwined with their local governments, managers, and visitors. And the stormwater and wastewater, because of this array of barrier islands and estuarine systems that sprinkles itself across the North Carolina coastline, they lend themselves to collaborative science because the systems in which we're so interested in tourism are themselves the recipients of failing infrastructure and what I would call engineering and compromise of the system. So we can use also this program or this research as a framework for also conducting education and outreach, which allows us to build more community learning related to stormwater and wastewater infrastructure. And the final point is, I'm sure as estuarine scientists across the board, that many of you recognize that coastal infrastructure is feeling an unprecedented squeeze, but I'll tell you a little bit more about that from the perspective of North Carolina now. Next slide, please. So as far as the scope of the problem, I think that this graphic really provides a nice representation of the persons per square mile on the y-axis and time on the x, showing you urbanization in coastal watersheds and showing you the coastal shoreline and inland counties and their growth as related to North Carolina. I think that this is a very kind of impactful graphic whenever you think also about the aging infrastructure. I yesterday just completed review of an undergraduate student's project using GIS mapping for the town of Beaufort, showing infrastructure that dates all the way back to the 1940s, 50s, and 60s. Combine that with the fact that over the course of this storm, we had the pleasure of experiencing, maybe not the pleasure, but we don't have any choice of experiencing Hurricanes Matthew, Florence, and Dorian, and had the ability to understand their impacts and the lasting impacts on the estuarine system. Next slide, please. The North Carolina coastal plain is the third largest low-lying region in the United States. As a matter of fact, when highlighting issues related to sea level rise, often the North Carolina coastal plain is used as a reference point for inundation. The coastal region itself also is expected to grow 26% within the decade. And this graphic actually just shows you an elevation model. So the area that we're working in is in the kind of the point of Cape Lookout, and you can actually see very nicely the impact of elevation and the lack of any sort of topographic gradient in this particular area. Next slide, please. So wastewater versus stormwater, it's important to talk here. Today, we're going to be talking mostly about stormwater, although a lot of our research in the town of Beaufort has been devoted on wastewater infrastructure. The important parts to describe are that these systems were engineered across eastern North Carolina and across much of the eastern seaboard of the United States as two separate systems. There are systems that are called a combined sewer overflow, in which you can expect that stormwater will funnel into a wastewater or sewage system, but in North Carolina that is not the case. They're designed separately, and the expectation is that the systems will behave themselves separately. That being said, wastewater itself is known to contain an array of contaminants. Today, I'll be talking primarily about microbial contaminants, but we should remember the impacts of nutrients, suspended solids, heavy metals, and dissolved organics on this particular system. Next slide, please. So when we think about the public health and economic significance of stormwater, we think about exposure linked with adverse health effects. As a matter of fact, there have been tens of research articles that have documented the increased incidence of gastrointestinal illness when recreating within the reaches of a actively flowing storm water system. The estimated annual economic burden of stormwater and non-point source contamination is $2.9 billion, and there is a current US EPA regulatory framework that's used really to try to manage inputs from storms. Next slide. So when we think about the town of Beaufort, yet again, I realize here that we've provided two different views. This is actually coming at the opposite side, if you will, from where Whitney was referring to previously. The mainland Beaufort is right in front of you with the majority of the trees and houses. The uninhabited island immediately to the top of the mainland area is the Rachel Carson Reserve, and the island that actually can be seen kind of atop of that is yet another barrier to our oceanic influence. Next slide, or actually next press. So if you think about the system, please advance it again, Nick. And you think about the impact of a barrier island, it's serving to protect the mainland entity, and it's also serving as a buffering, if you will, and an exchange or a flux of materials that's coming from the mainland area. Next. When we talk about the town of Beaufort, we're talking about an area in response to storms that is very, very close to the Rachel Carson Reserve. So you're talking just a few hundreds of, or maybe even just 100 meters away in some locations, and the area can be completely impacted by storms during larger events. The entirety of Taylor's Creek can be impacted by some of these contamination inflows. Next. So when thinking about microbial contaminants, just a quick primer on fecal material. Most people recognize this in the age of COVID and in the age of increased conversation about viruses and bacteria, but there are pathogenic viruses found in fecal material as well as bacteria. The ones that I'm highlighting on this particular slide are human in nature, although there are sources of other types of bacterial pathogens like Salmonella and Campylobacter that we need to be concerned about. For the purposes of this project, because we're working in an estuarine system and they're largely problematic more in freshwater systems, protozoa would need to be considered in a freshwater system, but in this particular case, they don't pose a significant risk in estuarine systems. Next. So you can advance it again, Nick, apologies. So when thinking about storms in historical research publications, if you think about a storm from a pre-storm condition as depicted on the x-axis, moving through the rising limb of the storm, the peak discharge of a storm, and the falling limb of a storm, you can actually imagine that in many publications over the past decades that you see an increase in microbial contaminants as you begin to discharge stormwater. These are just representations of concentration. These are not loading estimates. You see at the peak of discharge a higher level of bacteria represented on the y-axis as either E. coli or Enterococcus fecal indicator bacteria, and then a reduction in the total amount of bacteria or the total concentration observed on the falling limb of the storm. I put this slide into the presentation because this is what's fairly typical and fairly well seen in the literature as related to the fecal indicator bacteria in relationships to stormwater runoff. One thing that I'd like to remind you of is that the state of North Carolina uses Enterococcus as its management tool, but over the course of this project, we sought to measure both E. coli and Enterococcus in our stormwater work to ensure that we were gaining a complete picture. They're two very different groups of bacteria, and I can talk to you more about that in the Q&A later if you're interested. Next slide. So a graduate student working in my laboratory, Dr. Matthew Price, and our team completed a project to examine this relationship of fecal indicator bacteria using a predictive modeling framework in this low-lying coastal system. Next slide, please. So the previous research has shown us that that stormwater is a main driver of contamination of our receiving water bodies along the North Carolina coastline. We have low-lying coastal terrain with minimal topographic slope, and that causes problems with the design and implementation of an array of stormwater control measures because there simply is not much in the way of gradient for any sort of treatment. So stormwater ponds and retention ponds are common. We have a semi-diurnal tide system with a moderate range, and we have been increasingly observing king tides that more and more have an impact on the behavior of the stormwater runoff in our coastal system. Although king tides were not a major part of our project, they are part of our current research. We do have previous predictive models that have been generated that are very valuable for protection of our recreational waters, but we had never worked in this particular reach of the town of Beaufort and Taylor's Creek in the Rachel Carson Reserve. Next slide, please. So showing you again a town of Beaufort, I'd just like to call your attention to the green dot that is called the Orange Street outfall, the blue dot, which is the Marsh Pollock outfall, and Ann Street, which is another one of our sampling locations that's interior to the town of Beaufort. So this is one full block inland away from the water of Taylor's Creek, and I'd like to make special note of that before we move to the next slide to tell you a little bit more about that. So in thinking about these two outfalls that I showed you that were right on the water, the Orange Street and the Marsh Pollock, in a perfect world, we would expect to see a situation that's shown somewhat on the type of graphic that we have represented here that shows you time on the x-axis, the water level as depicted in the blue, which is basically the tidal fluctuation, and the velocity of the water during any particular storm event in the orange. And what's being shown here is that the water level and the velocity are, they're behaving somewhat separately from one another. Next slide, please. In the reality of what happens in the outfalls that we study in the town of Beaufort, we actually have a situation where the setup is very similar. Now, apologies, but discharge is actually on your left y-axis. The water level is on the right. The water level is depicted now in the gray dotted line, and the blue is depicting the discharge. But what you can quickly see is that the coincidence of high tide periods in the town of Beaufort actually depresses or makes it such that the water that should be discharging out of the outfall is held back or retained. That is not the way our stormwater systems in the state of North Carolina were designed. They were originally designed to move water from the landscape into receiving waters for both human health and human safety. Next slide. So when we think about the schematic of coastal towns, when we started this project, we thought we were looking at stormwater and stormwater runoff impacts, but we quickly became aware and keenly in interest of determining the impact of tidal height on the discharge of stormwater runoff along the town of Beaufort, because of the fact that it is similar to one of hundreds of coastal towns that can be found across Georgia, South Carolina, North Carolina, and Virginia. Next slide, please. We conducted work to identify or to collect samples from these multiple locations during both ambient conditions, storm conditions, and according to a tidal categorization. The tidal categorization was considered to be in an inundated situation, so that's less than 2 hours from high tide, a transition situation, which is 2 to 4 hours, and the receding, which is basically the low tide condition. Next slide. From there, samples, water samples were analyzed using a wide range of methods. I won't be telling you today about the research work of Dr. Mike Peeler and his laboratory on nutrient and sediment dynamics in the discharge. But today I'm going to be telling you a little bit about the fecal indicator bacteria, the Enterococcus and E. coli, and the microbial source tracking markers that we were able to track using quantitative PCR. Next slide. Using a wide array of microbiological methods that are EPA approved and also attending to quality control for our quantitative PCR analyses, we were able to accomplish a really nice distribution of sampling across our 3 locations. So there in the outside circle, you see in the green, the Orange Street representation, the red with the Ann Street representation, and the Marsh Pollock in the blue. We were also able to characterize across evenly across tidal condition, across inundated, transition, and receding situations, and we were able to characterize dry and wet conditions. So we had a really nice array of conditions that were balanced across these a range of different treatments. Next slide. So the main point that I'd like to recall is that I showed you before that Ann Street is actually inland to the town of Beaufort, 1 block inland. This graphic, if there's anything that you take away from it, should show you that the log value of any particular contaminant that was being measured, either E. coli, Enterococcus, or the human marker, HF183 along the bottom, with Enterococcus also being measured using a qPCR method as advocated by the US EPA. What I'd like to show you is that we were very surprised upon original estimations to understand that the Ann Street stormwater was far more contaminated than that of the Orange Street outfall and the Marsh Pollock outfall, and it left us scratching our heads. So either there was a sewage pipe break at Ann Street, or there was something else going on at Orange Street and Marsh Pollock. And you guessed it, what was going on was that during sampling, we were actually seeing dilution of the stormwater runoff due to the input of the tide. Next slide. So moving along here, I'm not going to focus a lot of attention on this particular table because it's a bit busy, but to show you, next click, Nick, please. to show you that when we did actually look at the Marsh Pollock and the Ann Street locations, that we found a substantial amount, next click please, amount of condition of time that the contamination was very, very high in these two locations. Next slide, please. And we actually confirmed as well the presence of human fecal markers in these systems, which Whitney will talk a little bit about later, which have actually resulted in infrastructure remediation that's been ongoing in the town. So the project has a legacy. Next slide, please. So when we think about consideration of the tide, we had to scratch our heads for a bit. We thought we were conducting a stormwater runoff and potentially a stormwater loading and discharge project. And we began to try to model tidal inundation in relationships to E. coli, enterococcus, and HF183, that human marker. The bottom line is that the punchline is that during inundated conditions, you can see that the concentrations of all of those microbial contaminant markers are much less than during the receding condition, which is during the low tide when the stormwater can actually flow freely out into the receiving water of Taylor's Creek. Next slide. When we think about this in this complex graphic, but I really like this graphic, we're able to visualize that it was not actually 24-hour rainfall that had the driving impact on fecal indicator bacteria concentrations from these two discharge pipes. Reminder that these discharge pipes are main discharges that are coming from the town of Beaufort. These are not tiny little pipes, and they're carrying a substantial amount of flow during our storm events. And what you can actually see is that the receding condition explains times whenever the very highest concentrations of E. coli, enterococcus, and human fecal contamination is coming out of the pipes. During an inundated condition, you actually see that that signal is depressed and held back, therefore allowing the system not to operate as it was originally designed. Next slide. So we sought in the course of the publication that stemmed from Dr. Price's graduate work to create a depiction of what we thought was going on in the town of Beaufort, because we think that it's replicated across the coastline. And interestingly, because we think that in most particular cases, we are not considering tidal stage in our stormwater monitoring, in our research, and certainly not in our regularly conducted routine monitoring of fecal indicator bacteria in most of our recreational systems. Next slide. So as far as the tide study conclusions, I'd like to say that even though the tidal inundation represented a serious head scratcher at the time for our collaborative project, that we were able to demonstrate the impact of the tide using this multiple linear regression model, that we are recommending now that that tide be considered in monitoring programs, and that monitoring programs that are based solely on rainfall, particularly across our mid-Atlantic seaboard and the southeastern coast of the United States, are problematic. We have much to do to understand the external factors that drive stormwater delivery. This was the first, if you can believe it, tidal inundation model that had been produced in the context of stormwater runoff and microbial contaminants from what we can understand across the world. We have not seen much of this actually published previously. And now king tides and sea level rise demand additional research on this topic. Next slide. So I'd just like to spend about 45 seconds telling you about an autonomous boat that we developed so that we could actually track what was going on in our estuarine systems. This is actually an image of Taylor's Creek, an autonomous boat. You can see the original design of the autonomous boat. It was version 1. It was a bit big. It was needed to be powered by someone sitting in the cockpit there. And we've been able to advance this technology to use this particular type of boat to track an array of different contaminants. And we hope to be able to use it in the future for chemical spills and sewage spills. And if you would go ahead, Nick, and just advance the video on it. There's some audio that went with it. Anyway, in using the boat, we can actually program its destination, and we can program a full set of transects. We can observe an array of different information using cameras that can be mounted on the boat. And we also are able to collect water samples that can be retained and taken back to the laboratory, thereby providing a much cheaper alternative for mapping of shellfish harvesting areas, sewage spills, chemical contaminant spills, and even hurricanes where it is not safe for personnel yet to be out on the water. You could be standing on land and manning a autonomous system such as this for tracking. Next slide. We have a lot more to come from this work, but I just wanted to show you a bathymetric plot of the turbidity of another system proximal to Taylor's Creek that we've been working on. And we have a whole set of publications that will come out from this autonomous boat and also tracking work. Next slide. So I will hand it over to Whitney, and she's going to tell you just a little bit about a few of our further collaborative efforts.
Thank you, Rachel. So just prior to this project kicking off, the town of Beaufort established a stormwater advisory committee to address flooding issues around town. And I ended up taking over leadership of this committee and added this project to one of the objectives of the committee to be the collaborative group to help inform this research project. There we go. So the Stormwater Committee was comprised of a diverse group of stakeholders, including Town of Beaufort administration, public works, and planning staff, as well as elected officials. The North Carolina Coastal Federation, which is a local environmental advocacy group, Duke University, State Stormwater Permitting Division, State Shellfish Sanitation and Recreational Water Quality Section, Eastern Carolina Council of Governments, and local residents. The committee met quarterly for about 3 years, and we met on the town's turf at their historic train depot, which is pictured here. So in addition to committee business, which was things like talking about Rachel's project and the implications of the data and how we can work on town infrastructure to address these problems that have been identified, we also had public comment at our sessions, and we heard quite regularly from citizens who are experiencing flooding issues in their neighborhoods. So as a committee lead, I jokingly called myself the stormwater whisperer, and committee members were not shy about telling me how they really felt about what was happening at the committee. So I think maintaining this level of neutrality as a committee lead really helped with the success that came out of our committee. And an important accomplishment of this project was connecting the town of Beaufort to these amazing organizations that operate in our county and helping the town bring those resources in to solve problems. So I really think of our collaboration as threefold. First, it was being an advisory group for Rachel's research that you've just heard about, and then also related to watershed restoration and improving town infrastructure. So watershed restoration sets the stage for the town infrastructure improvements. The North Carolina Coastal Federation led the development of a watershed restoration plan in partnership with the advisory committee. And we secured funding to complete the plan, and it was adopted by the town's Board of Commissioners in 2008. And I believe that Megan is going to put the link in the chat box for the watershed restoration plan. So this plan makes the town eligible for federal funding through the Section 319 of the Clean Water Act for water quality improvements. This plan uses a stormwater reduction philosophy to improve water quality and stresses the importance of matching capital improvement projects with stormwater retrofits. And when I talk about stormwater reduction philosophy, what we're saying is reducing the amount of volume of stormwater that is leaving the land and entering the receiving waters. So it's essentially turning back the clock on where we were pre a certain level of development. And I believe we went back to 1993 level of development for this project. And the North Carolina Coastal Federation, after the plan was complete, secured funding for several projects, and I'll talk about a few of them here. So one of these projects was the installation of pervious pavers at one of the town's boat ramps. And if you see those gray areas that are between the black asphalt, that's the pervious paving. And here we used eco raster grids. These are essentially like plastic forms that they sink in and they put gravel over them. And those were installed in the parking bays to help absorb stormwater. You heard Rachel talk about Orange Street. That was one of her sampling sites at the pipe at the end of this road. And this was an area of concern that the town ended up tearing up and repairing underground utilities here. This is in the heart of the town of Beaufort's historic district. And this is a perfect example of matching capital improvement with a stormwater retrofit. So while the road was torn up to repair the sewage pipe, the road was repaved and a strip of permeable concrete, you can see it on the right, was laid in the parking lane to reduce the volume of runoff reaching Taylor's Creek. And then another project involves the town's old highway. So a few years ago, the old drawbridge was replaced and a high-rise bridge was used to connect Beaufort to the rest of the county. And this road in Cedar Street still belongs to the state highway system. This road is like third world country. It's like potholes, it's awful. And there's all these pipes that are torn up underneath. So the North Carolina Department of Transportation is required to repair this highway before they turn it back over to the town and fixing all those underground utilities. So through the Stormwater Advisory Committee, we connected two factions of the North Carolina Department of Transportation. We connected the engineers tasked with the road repair with the DOT's highway stormwater program. So through the NCDOT highway stormwater program, we were able to secure additional resources for the town. This includes another project of pairing capital improvements with stormwater volume reduction. And with state funding, 14 underground stormwater bioretention cells are planned along the length of this road, which is really exciting. And finally, this collaboration helped the town of Beaufort receive a $23.6 million package, which is unbelievable, of low interest loans and grants from the U.S. Department of Agriculture for a major overhaul of water, sewer, and stormwater infrastructure. So Dr. Noble assembled this project's data on human fecal contamination and put it into a package of information about failing infrastructure, which helped the town secure this USDA funding. So now I'm going to turn it back over to Rachel, and she's going to talk about our project's community education efforts.
Great. Thank you, Whitney. And so now we'll move on. Nick, I'm just going to go ahead and have you advance the slides just to avoid any problem. I'd like to tell you all a little bit about an excellent collaboration that we formed across the Institute of Marine Sciences here in Morehead City, North Carolina, with the Duke University Marine Lab, which is part of the Nicholas School of the Environment, and NC State University. And you might think it's strange at first to combine citizen science with plastic pollution and water quality, but I hope to demonstrate to you that this kind of package of work has allowed us to advance our ability to create community learning and actively engaging education programs. And the hashtag that was created as part of our teacher workshops was Think Outside the Sink. So if you're interested, you might see that on other forms of social media. Next slide, please. So the first question that we asked ourselves, and really had already been asked by collaborators, Dr. Liz DeMattia and Catherine Stevenson from Duke and NC State, is why work with kids? But I just want to remind everyone that the ability to work with kids provided us with local connections. It allowed us to help the schools create hands-on learning activities and even field trips out to the Rachel Carson Reserve, where hundreds of students were able to enjoy the Rachel Carson Reserve and learn about stormwater and water quality all at the same time. When we think about working with kids, I think Nick is trying to get us back to where we were. But initially, if we think about one scientist like myself working with kids, you might have a reach of 20 students if you're operating as an individual. If you're actually operating in the course of working with teachers, what you have is you have a situation where you can reach more students. But in the framework that we developed, where we're actually creating, actively creating workshops that engage both teachers and therefore later students, we're able to engage with hundreds and thousands of total members of the community. Maybe you can move on to the next slide, Nick. Maybe that'll help. So we have developed teacher training programs, particularly centered around marine debris and stormwater. What these are teacher-based workshops where we work with the teachers, particularly in the state of North Carolina, to develop the lesson plans that will transition easily into a high school, middle school, and elementary education format, accomplishing a major amount of the North Carolina standards associated with the water cycle, stormwater runoff, and also teaching about environmental and ecosystem impacts. We've strived with our teacher training programs to actually integrate into the North Carolina environmental science program so that we can engage teachers at the high school level and continue to engage students in hands-on activities. You can see a headline from a peer-reviewed journal publication that was co-authored by some of our collaborators that actually allows you to see a link between understanding something about marine debris and policy and community engagement, community education. Next slide. So when thinking about our citizen science and community science, I tried to explain this before, but working as an individual, you might have a reach of 20 students. Working as an individual, working with maybe a single grade of a school, say, with multiple teachers, you can engage even more students. But what we've actually conducted is the ability to generate a community learning program that allows us to work with teachers and teachers then to work with large groups of students and other teachers at their particular schools and school districts. Next slide, please. By doing this, we've improved the reach of our ability to engage students, but we have really, what I didn't mention previously, is we've really taken off with the idea of intergenerational transfer. So what you actually see is a reciprocation of the training that goes on at the student and teacher level back into families where by coming home and after doing hands-on activities, students from an array of different grade levels are actually returning back to their homes and teaching grandparents, parents, and siblings all about stormwater and plastic pollution, thereby increasing that reach that was mentioned before. We decided to do work on stormwater, and you can see why, because many of the items that are held up in a stormwater runoff kind of context that you can see here from a photo that was actually taken in the town of Beaufort is that it's an affordable way to begin to think about contamination coming into our coastal waters. It can act as a model system, and even though in my laboratory we're focused largely on things that we can't, as scientists, we can't see them. We can't see fecal indicator bacteria and genes floating around in the water. We can actually see some of these larger forms of contamination, and we can translate these kinds of pieces of information into a further understanding of some of those more abstract contaminants that are present in stormwater. Next slide. So just telling you a little bit about what we did. We developed a water quality curriculum. That water quality curriculum is actually available on the Science Collaborative website. We also developed an app where students can actually go out into their own school or their own town, and they can adopt a drain based upon geographic information, and they can begin to track and clean the material that comes into the drain, thereby improving our ability to teach students about stormwater and plastic related pollution, but also allowing them to gain agency about their own environment and connect more with their classmates and their teachers on things that matter to them and their own environments. Next slide. So I'd just like to end with the idea that there are a lot of opportunities for the classroom preparations to be shared. So far, we've done a lot of this work across the state of North Carolina, but if there are those of you who either have connections or you yourself are interested in translating this information, we are interested and have begun to investigate the ability to transition this to more of a national framework by talking to nonprofits that have a national level of reach. Next slide. So when we think about the work that's been conducted in the town of Beaufort, I think that we had a highly successful research project. We could have never anticipated the impact of tidal inundation on the town of Beaufort, and in ensuing years or in ensuing months, we've actually heard more and more about the woes, and I'm sure many of you have seen pictures of sunny day flooding that have been shown on the internet from all along the eastern seaboard. We're continuing to use the work that we conducted in the town of Beaufort and as part of the Science Collaborative to understand the role of flooding and precipitation and tidal inundation. And this is still driving active projects to this day. As you could tell from Whitney's presentation, the infrastructure modifications that are underway in the town of Beaufort are just now getting really underway in a major way. We have developed improved technologies for measuring pathogens rather than only focusing on indicators, and that includes that autonomous boat system that I hope you'll read more about in the future. And we are actively continuing the development and the implementation of these teacher workshops and community learning, and we have multiple projects that are stemming from that particular line of work, along with the Duke University Marine Lab Community Science Initiative. Next slide, please. So I'd just like to put really into words this acknowledgements page. I am absolutely certain that there are people that have not appeared on this page that have made major contributions to our very large collaborative project, but I would like to call attention in particular to just a few people who are not presenting or kind of seen with us here today. That's Dr. Matthew Price. He's now residing up in the state of New York. Dr. Mike Peeler, who is my technical lead on this particular collaborative project and headed the nutrient and sediment side of the work, which you didn't hear much about today. Liz DeMattia, who was our collaborator at the Community Science Initiative at Duke University Marine Lab, and Lori Davis at the Coastal Reserve, who served as our education coordinator. And with that, I'd like to thank you all for listening and take any questions.
Okay, Q&A time. Made good time there, so we've got about 15 minutes roughly for Q&A, and we have a few that came in during the end of the presentation, so I'm just going to scroll forward here to the last little slide, which I think we have here. Yeah, Q&A. So just a reminder, you can ask questions by entering them into the GoToWebinar console. Don't be shy. We'll just verbalize them for you because, again, organizers are the only people who can see the questions, so I'll have to verbalize them for you. So the first question we have is, could you elaborate on the choice of E. coli monitoring and also if any ambient monitoring was conducted?
So the E. coli is a fecal indicator bacteria that's used by many other states. Actually, many coastal states manage their water quality using E. coli or fecal coliforms, of which E. coli is the predominant kind of member of the fecal coliforms. And because other states use fecal coliforms and E. coli, although the state of North Carolina doesn't, and also because E. coli is a single species, we feel that E. coli allows us, when we conduct the monitoring work in relationship to stormwater, we feel that that provides us with information that's going to be specific to fecal contamination from warm-blooded animals. I think the second question was about ambient conditions.
Yes, ambient
but
monitoring.
I don't know if we can return back to the slide, but the slide that was basically that circle graph shows you that we devoted quite a bit of attention actually to monitoring during ambient conditions. It's the one that looks like the big colorful circle next. Yep, right there. So if you look at it, you have dry and wet weather represented in the very inside of the circle. The dry would be the ambient condition, no measurable precipitation. And then the wet weather would have been the other measurable precipitation driving that. So we had to have measurable rainfall to qualify as the wet. And so this is a data set that stems over, I think we wore Matt out, my graduate student, but I believe that this represents something in the neighborhood of 45 to 50 full sampling events that categorized either as a dry or wet condition. So a lot of data generated in this particular project in ambient condition that acted as our baseline for our model development.
Thank you. Okay, more questions rolling in. So I encourage everyone to keep them coming. So somebody is asking about the elevation of the near shore area. So they want to know what the elevation is, especially the Ann Street location.
0. No, it's I know that we have the pipe elevations from all of the pipes in Beaufort, but I would strive to say that the elevation in any case for the majority of the historic parts of the town of Beaufort is probably between 18 inches and 3.5 feet, something in that. We do have higher elevations that exist in other of the incorporated areas of Beaufort, which get to be a little higher in elevation given its Pocosan nature. But when we're talking about the downtown reaches of Beaufort, you're talking about a very low-lying entity.
And
I
we
don't
had a
know,
follow-up
Whitney,
question.
if that sounds accurate to you. Yeah.
Sorry, I didn't mean to jump in there. We had a related question from the same person, just following up, wanting to know what the height of the tides were and whether or not you were able to get retention times of water.
Our tides in the town of Beaufort are 3.1 feet generally, or about 1 meter. But we will, just this week, we will experience a king tide event, for example, that will put us somewhere between 14 to 18 inches over our high tide, our mean high tide value. And our tides, for example, during for 2 months following Hurricane Florence, ranged our high tide. So as compared to 3.1, we were getting somewhere in the neighborhood of 4.5 to 4.8, simply from excess water flowing towards the ocean, towards our coastline in the state of North Carolina. So we can actually see quite a bit of increase locally in our water levels associated with the mixed effects of tide, wind, and storm.
Thank you. Okay, more questions rolling in. See if we can rapid fire through them. Was sea level rise taken into account in the update of the stormwater system?
Our stormwater system at this point in time has not been updated, but they did replace a sewage pipe. So the stormwater conveyance system that we would be referring to, where the discharge is coming out of those pipes, like the Marsh Pollock outfall and the Orange Street outfall, are subterranean sewage pipes that are 36-inch pipes. The modifications that Whitney was telling you a little bit about are all on the surface of the land, but no major sewage remediation has been done at this point. And the reason why I think that's the case is because attention is being paid to improving the wastewater infrastructure and fixing known compromises in the sewage infrastructure system, including lift stations and also gravity lines. And then once that is completed, a new assessment will be done, and subterranean stormwater conveyance, like pipes underground, will then be attended to. But so far, in large part, unless there's a major crack in a pipe that needs to be immediately replaced, the stormwater management has largely been on the surface of the land. So those kinds of pervious pavers and things like that Whitney talked about.
Okay. All right.
Does that seem accurate, Whitney? Is that good response? Okay.
Yeah, just feel free to jump in, and especially if you want me to just stop rapid firing questions and elaborate, and feel free to just cut me off. So next question, if there's no other thoughts on that one, is it possible that the higher salinity of tidal water affected the lower count of fecal bacteria, or was it simply dilution?
Both. Very good point. So not to get into the microbiology lesson, but Enterococcus, if you grow them in a laboratory, they're actually grown at 6. So the salinity of the ocean is about 3% or 35 parts per thousand. So when you grow Enterococcus in the laboratory, a lot of people think that the bacteria just die when they get into salty water. You actually grow them in the laboratory at about 6% salt. So they don't care. So largely the Enterococcus would be expected to simply be diluted, and possibly by shock from the salinity, they could actually be impacted, but the likelihood is low, whereas the E. coli response is probably such that they're either dying or at least not being measured appropriately in our laboratory-based methods, because they're not surviving as well as they were whenever they came out of the gut or were present in the fecal material. So very, very good question. The basics of understanding the role of tidal inundation was completed in this project, but we have much to understand as far as delivery and dynamics of microbial contaminants into systems, and then considering the tide on top of that.
So this next question has a few parts to it, and I think you can both feel free to weigh in on this one, because it's kind of it's broad. There's a few parts to it, so it's a couple questions rolled together. So is the public aware of water quality issues, and how do you weigh their concerns? And there's kind of some follow-up questions, so maybe we'll start with this first one, and then I'll kind of
Let Whitney take that one first.
Sure. So we have an excellent mayor in town, Rhett Newton, and he has made Beaufort being a clean water community a priority. So he has elevated that to one of, say, 5 focus areas for the community. I also conduct a lot of my workshops in Beaufort, because that's where my office is, although I do programs up and down the coast here in North Carolina. And so we're regularly talking to folks like realtors and engineers, marine contractors about water quality and things that they can do, such as low impact development and living shorelines to help protect water quality. So I think we're helping with that. I would say we had a pretty extreme king tide the other day, and I think that's bringing a lot of people's attention to not just water quality, but also the sea level rise issues that we're going to have here in the near future.
Anything to add, Rachel? There are some follow-up points which you might address.
Yeah, I would just go ahead and say that I think the onslaught, if you will, with COVID, in terms of just microbial conversations, viruses and bacteria in everyday life, the increase in local awareness as associated with extreme events, so tropical storms, hurricanes, nor'easters, and then layered with the king tides, and then layered on top of that with the fact that we are primarily, or historically, we're primarily a fishing community, and a location that's prominently known for tourism as the driving parts of the economy, is that I would say that compared to a lot of places in the country, that the public is keenly aware of water quality issues, but also that many of their water quality issues probably relate more specifically to their homes, flooding of their yards, and more kind of the standing water flooding as a first concern, and maybe the microbial contaminants being in the water itself might be a secondary concern.
So there are some kind of follow-up questions that other people were asking, which I think are getting to that point as well. Somebody wanted to know if the communities begin to talk about relocation needs to avoid the increase in flooding and exposure to water contamination.
That's a great question. So we're actually working on a highly collaborative project that was funded through the University of North Carolina at Chapel Hill by NSF. It's an NSF convergence project. So it brings together urban, city planners, microbial expertise like mine, physical oceanographers, people that study flooding and storm surge. And the answer to your question is that a major part of that is actually associated with understanding floodplain impacts from extreme events, and identifying buyout solutions for the state of North Carolina. We're making some progress on that, but as you can expect, there are a lot of entangled issues related with relocation and with buyout. And so while I am not aware of any buyout conversations that are specifically being had in Carteret County, those conversations are being had in some of the other low-lying areas of central North Carolina.
Anything to add, Whitney?
I would just say that that's a really hard conversation to have, and I'm not looking forward to having to have those and how the reserve might support those types of conversations, but that's a very complex issue that really, you know, I could see the integrity of Beaufort really being impacted by those types of decisions. So not looking forward to that in the future.
We have one more question here. I just want to try to squeeze it in the last minute. So we'll see if we can just give a answer to this last one. How do you address concerns outside the jurisdiction of Beaufort, like problems caused upstream by farms or other things?
That's a great question too. We've actually been conducting research across the whole state of North Carolina. And so I think a lot of our coastal towns are facing common concerns. I would say that we started addressing this issue by trying to develop a community of practice, actually, as part of this project on stormwater runoff, involving the coastal towns as members of that community of practice. And it literally, a workshop to develop that community of practice was held exactly 1 week before COVID the first time hit, so March of 2020. And we haven't achieved the same momentum on it, but it is something that we still hope to work on. And I hope in the future that possibly we can work with the Coastal Reserve office and work with Whitney to try to bring that to fruition. But
Whitney, you get the last word if you want it.
Well, I look forward to, you know, we've been working on stormwater issues for so long through the North Carolina Coastal Training Program. So looking forward to continuing these conversations and just so excited about all the work that we've supported in the town of Beaufort and the improvements that are happening around town.
Thank you both. Well, we are over time. I just want to quickly thank both of our presenters for the excellent presentation and for sticking around to answer some questions for us. We do appreciate that. I will make sure to post the recording to our website and to YouTube within the next few days. Remaining questions, if you have them, you can feel free to put them in the exit survey. If something just clicks in your head after the fact, you'll get a link after you exit the session and tomorrow at around the same time as the webinar was today, so 2 p.m. Eastern. You'll get a link, an email from us automatically with the exit survey. So if you have other questions that click after the session that you want to ask, you can feel free to put them in there as well. Our next webinar will be next week, same time, December 7th at 2 p.m. Eastern. You can feel free to sign up for webinar announcements or program updates to stay on top of upcoming webinars and new resources. And with that, one last big thank you to our speakers. Thank you for joining us today, and I hope you enjoy the rest of your day.
Thank you very much.
Thanks, Nick.